So, quick recap: a prototype is a preliminary version or a model of a product, service, or process. Now, as even you would start building your prototype, let's discuss some do's and don'ts. When you build your prototype, avoid unnecessary features. Keep it quick and minimal. Remember, the purpose of your prototype is to align the team for building that future final solution. Always treat your prototype as a living document and not as a finished product. Also, ensure that your prototype communicates the vision of your product or service. Some don'ts. When you build a prototype, don't over engineer. Keep it simple. Do not fear failure, it's part of the game. You learn from your failures. Do not fall in love with your prototype. Do not get attached. Remember, you have to stay open to changes. Don't confuse your prototype as a final product. Before it goes to the final product, it has to iteratively go through multiple changes. And finally, don't forget that you're building a prototype for learning purpose and not to launch for actual set of customers. When you build a software prototype, create something by determining how users will interact with the software. Do not get boggled up by focusing on database or other backend design systems. You can create simple wireframe and mockup of your software by using tools like Blastmake, Sketch, or Figma. You may also use tools such as Adobe XD, InVision, Axure, Bubble, etc. for creating interactive prototypes. When you're creating a product prototype, start with a simple sketch on a paper or a digital drawing tool. You can also create 3D models using SolidWorks, Tinkercad, Autodesk Fusion, Blender, etc. You can also use materials like cardboard, faux, or 3D printing to create a close enough physical representation of the product.
Hello Internet, my name is Waffle and I'm a maker at Discovery Place. We're in my 3D printing workshop at home and I'm here to talk to you about how you communicate with 3D printers. So last video we talked about how 3D printers worked, they added up layer after layer after layer to make a solid object. Here we're going to be talking about the software and how you actually get that design into the 3D printer. Most of you have seen normal paper printers before. You take an image that you either draw at home or download off the internet and then send that to your printer, and the printer will print it out on a sheet of paper. A printer doesn't do anything just by itself. And likewise, a 3D printer actually needs a 3D image to print. If you tried to send it a standard 2D image, like a GIF or something, it wouldn't know what to do with that. And so we actually need to design a special type of file to communicate with 3D printers. So let's look at this object. If you look from the front, you can see that it has one outline if you were to trace it. But if I were to rotate it 90 degrees, you would have a different outline. Or if I rotated it 90 degrees up, you have a different outline. And so really this object has a bunch of different outlines from different perspectives. And so we need a file that can actually talk about all of these different perspectives and all of these angles at once. And so what we actually use is we use a bunch of triangles. These are called, it's an STL for stereolithography. It's just one of those science words. And you create a bunch of triangles and kind of tile a surface. So you could tile a bunch of squares and it would be flat, but with the triangles you can actually start having curvature. If you have lots of triangles, the triangles are very tiny and it's very detailed and smooth, but each of those triangles takes up space in memory for your file, and so your files can get very big. If you reduce the number of triangles, you can reduce the size of the file, but you get lower resolution on your model. So one of these places to think about this is video games, where high polygon video games, very nice, everything looks kind of smoother, but if you tone all the settings down, everything gets really blocky because it's easier to work with fewer polygons. Now, before we start modeling anything, it's always a good idea to kind of plan and think about what we're going to make. And so today I'm going to sit down, just grab a sheet of paper, and I'm going to make a house to show us. And so the house is actually going to be pretty simple. I'm just going to say, I'm going to draw a box for the body of the house. I'm going to draw a roof, maybe a rectangle for the doors, 2 circles for the windows, and a little chimney. And now that I have drawn and designed my house in 2 dimensions from one perspective, right, I can load up my program and we can start designing the actual house. Now that we have our plan, we can start modeling. I'll be using the website Tinkercad at tinkercad.com for this video. You can make a free account and create a new object, and you'll be confronted with this workspace. Tinkercad works primarily through the moving, scaling, rotating, and removing of basic shapes. If you look on the right-hand side, there'll be a bunch of different objects, and you can click one and then click in the workspace and it'll appear. Now, when the object's there and you've selected it, you'll see a bunch of different boxes appear. These let us scale it. So if you grab a box, you can move it bigger in the X direction and the Y direction. If you let go and grab on top of the box on top of the object, you can make it taller. But then if you want to lift the thing into the air, you actually have to grab the black arrow and lift things into the air. You see, if I click and drag the object around once it's lifted, it will still move around the XY plane, but it will stay at that height that I lifted it. And then you also have 3 sets of curved arrows on 3 different sides of the objects, and these are actually to let us rotate it. And you have 3 different axes so that you only do one type of rotation at a time. Now we've learned the basic building blocks of 3D modeling. If you want to remove and place blocks, and if you want to make something more complex, you just add a bunch of different blocks together. By combining these different things into different positions, you kind of worked your way to make a 3D image. Now, while this is the most of the work, we also have to make sure that everything turns out and looks nicely. So, to demonstrate, I'm going to make a house. Now, to start my house, I'm going to put a block in the center of the plane. And that's pretty good. I'm then going to scroll and find a roof, and I'm going to click and place the roof on the plane. And now I'm going to kind of lift it up to the height that I think it needs to be, click and drag it until it's on my house. And it looks like it's on my house, so I've done a pretty good job, right? Well, we have to remember that a 3D model has different perspectives. You can look at it from different angles. So you can either use the navigation cube in the top left or right click the empty workspace and kind of pan, and you'll see that, oops, no. It just looks like the roof is on my house because of the perspective I was at, but it's actually not on the house. So I'll click the roof, I'll move it a little bit again, line it up better, drop it down a little bit, and ta-da, my roof is on my house, right? Well, we need to check it again, right? I'm going to rotate and look at that. It might not quite be on my house. So whenever we're 3D modeling and designing things, we definitely want to be sure that the pieces are one solid piece. So we want to rotate and look at it from all the different directions to kind of get it to where we want it to go. And sometimes it can take a little while, but it's very important that we make sure whatever we're making is actually 3D and not just we think it's 3D because we've been looking at it from one direction. Now that we've learned how to combine things and make a solid object, let's finish up our house so that we can send it to the printer. To make the door, I'll just take another square block and put it down, maybe make it a little bit skinnier and a little bit shorter and put it in the middle so it sticks out a little bit to make the door. Get a cylinder that then I can change the radius of and rotate it, and then make it a hole so I can kind of punch holes into the front of the house to make windows. And if you have one object that's the right size you want and you want to make another one, you can Control-C, Control-V, copy-paste to make another duplicate image. And so I got my door, I got my windows, last is the chimney. So I'll take another block, I'll make it very skinny, make it very tall, and then I'll actually select both it and the house, and I can use the fancy Align tool to the upper right to make sure that it is aligned to the center of the house and the side. So that way it's even on either direction. And you do give your model one final pan around, kind of looking from all directions, and now you can export your model to be printed. Now I've imported my model into my slicer. The particular slicing software I'm using is Ultimaker Cura. It's open source, available for free on the internet, and it's what actually talks to the printer. Now before I talk about any of the fancy things the slicer does, let's just slice my model and see what happens. Now that I've sliced my model, what we can do is you can go to Preview tab and see what it's going to look like. I can grab the slider on the side and actually drag up and down and see the layers as they're printing. And so you can definitely see how this printer is working layer by layer. But let's go to the very first layer to see how it works. In the first layer, you can see that the 3D printer starts with the outline or perimeter of the object. It'll draw a couple paths on the outside to give it strength, and then start filling in the inside. You'll see it moves one line, moves over a little bit, and goes back. And it repeats this back and forth until it fills in that bottom layer. It will then do this a couple of times to make a nice strong bottom layer, but then it'll actually start doing something different when it moves up. It'll still draw the perimeter to make it strong, but as opposed to making the print solid plastic, it'll use something called infill. And so this is a pattern of plastic on the inside that gives it strength while still keeping the object mostly hollow. So one of the fun things to look at is different patterns for infill. We have very basic ones that's like a grid that you can see isn't actually three-dimensional, it's two-dimensional that just repeats. You have stuff like cubic or a very cool curvy gyroid. Some of these are more optimized for printing things that are taking stresses and strains, but regardless, they all print pretty well and they all do their job of making the print faster while still giving it strength. And now that we've sliced our model, let's send it to the printer and see how it goes. Well, I'd like to thank everyone for watching our video. I hope you learned a lot about 3D printers and the software. If you want to make your own models, you can use Tinkercad at tinkercad.com, create a free account, sign up, start making things. If you want to make your own house, a boat, maybe a gecko. If you make anything cool and you'd like to share it with us, you can post a link in the comments below. Thank you very much, everyone. Have a good one.
Now, when you're creating a service prototype, create a service blueprint that outlines the customer journey, front stage and backstage actions, and touch points. You can also create the customer journey map, a geographical representation of the customer's experience with the service, detailing each touch point and emotional state. You can also role-play the service to understand and improve the customer experience. This can be also done through storytelling.
Hi, I'm Megan Grocki from MadPow, and today I'll be showing you how to create customer journey maps. Journey maps are a visual interpretation of an individual's relationship with an organization, service, product or brand over time and across channels. A journey map helps us explore answers to the what-ifs that arise during research and conceptual design. They should include items like personas, a timeline, the emotions being felt by customers, touch points, and channels where the interactions are taking place. So how does one create a customer journey map? There are 9 key steps. Number 1, review the goals for the product or service. Number 2, gather our research. Some of my favorite research methods include customer interviews, contextual inquiry, customer surveys, customer support logs, web analytics, social media, and competitive intelligence.
Number 3, generate a list of customer touchpoints and the channels on which those touchpoints occur. For example, the touchpoint could be pay a bill, and the channels associated with that touchpoint could be pay online, pay in person, or pay via mail.
Number 4, conduct an exercise called an empathy map. Empathy maps depict the various facets of a persona and his or her experiences in a given scenario. The goal of the empathy map is to get a sense of how it feels to be that customer in this experience. Number 5, brainstorm with what we call lenses. This means we generate ideas in a short period of time with words representing key concepts, brand attributes, or mindsets that help us look at a problem in a different way. Number 6, complete an affinity diagram where we organize ideas and find cohesion in the team's concepts. It helps us focus on the right solutions for this audience. Number 7, this is the part you've been waiting for, sketching the journey. This is where we put together all the ideas the team generated for how to improve the future customer journey. Get creative on how you lay it out. There's no one way of sketching a customer journey. Number 8, refine and digitize. If visual design isn't your strong suit, consider collaborating with someone who can turn your journey map into an impressive artifact. And lastly, number 9 is to share them with zeal. Shout from the rooftops and display them prominently in common areas. That's all. I hope you found this useful, and best of luck in creating your own journey maps.